place to start is to first find the mins and maxes. You have 3 mins and maxes, you're going to go through that x-axis 3 times. Okay? Now, what do all these, before I get to 2, what do all these tangent lines have in common? They're all slopes, yes. All tangent lines slopes. When such ones is what make them tangent lines. Come on, more specific guys. They're all positive. Can you agree with that? And they're getting less steep. They're all positive slopes. They're going up. Right. Pay attention. Well, that was you zoning out right there.
What? What was it?
Anyway, they're all positive. Because I said before 2, what happens?
Okay.
Yeah. So they're all positive. So in my graph, before I hit 2, I better be positive, which means above the x-axis. So I know I'm going to be positive until I get here. Okay? Then let's look afterwards. Oops. Picture those tangent lines here. What do they all have in common? Negative until I get to 6. So I know I've got to be below the x-axis here. And after that, positive again, above the x-axis. Now we could get very specific. We're not going to be that specific here because I could literally draw a tangent line, and since this graph is actually labeled, I could say, oh, you go up 3 over 1 and get very specific. But we just want a general shape. I know I'm positive, go through here, I'm negative, I've got to go positive again. You want the general shape. Now notice the derivative of a curve is going to be a curve for the most part. There are a few exceptions. Yes? The reason for that is the slope is always changing, yes? But when we get lines, which we're going to get in a minute, that's going to change. I mean, the slope's going to be constant. We don't use this method for lines. Lines, you can see the slope. But here, the slopes are constantly changing. Now, second period, you have a handout matching graphs. Looks just like this.